All right, data distribution. We talked about different data types. When you have a continuous variable, that you need to think about the distribution of the data. So if you were to look at a frequency, what does it look like in a graph? And here's a demonstration here. A Gaussian normal, sometimes called a bell curve, and you think about how they set where test is going to be a B versus an A versus a C, thinking about a normal distribution for grades in a class. The mean, median, and mode that you already heard about are identical for a Gaussian curve. Also important to note, for Gaussian or normal distribution, that allows you to use a parametric test. We'll talk about parametric tests in further modules. There'll be an analysis of variance, a t-test. Parametric test, normally distributed data. Non-normally distributed data, which are skewed, and we'll talk about that in just a minute, you have to use a non-parametric test. And again, we'll talk about those in future modules as well. But let's take a look in this figure about what that does to the mean, median, and mode. So on the bottom left, you see a positively skewed continuous variable. And you see on the right, a negatively skewed. So you've got a tail either to the right side or the left side of your distribution. For both, regardless of which direction the skew is, you see the mean moves away from the median, and again, median, half less, half greater of the values. You see the mean move towards the tail where you've got skewed data, where the mode stays more towards the middle again, because it's the most common. And then in the next slide, we're going to look at bimodal or trimodal. These three parts of this figure show a mode, one most common value in these continuous data points. For bimodal, you have two modes, trimodal, three modes. You can have more than that, but not usually with a biological data point. So let's go ahead and look at some different modes. And a bimodal and a trimodal distribution, again, bimodal 2 modes, trimodal 3 modes. And this comes from an article on the change in epidemiology of trauma deaths. And looking at, important to note, the scale here, the left-hand side of the figure is in hours, from 0 to 4 hours, immediately following a traumatic event such as a motor vehicle crash. On the right-hand side of the figure, you notice that the time frame is weeks, so those delayed deaths after a traumatic event. And then in the dark curves, you see the bimodal versus trimodal. If you were to look at them, again, just separating out hours and weeks, you see almost a normal distribution on both. Bimodal. If you include those immediate deaths, within the first 30 minutes, that's where you get your trimodal. So again, trimodal 3, bimodal 2.